The good old days always seem to be better. Looking back into the past, we can't help but think that everything was somehow bigger and more impressive than its modern counterparts. So, if you took a few steps back and dived deep into the prehistoric past, you would discover that everything was just like that. In fact, not only the grass was greener, but it was also taller. And the air was thicker too. Some of the insects that were flying among the towering trees and the bugs crawling down in the grass below looked so creepy they would easily petrify any modern person. Our today's list features exactly these kinds of monsters that would send creepy crawlers down your spine in no time. Brace yourselves, as in today's video you'll discover dragonflies the size of an eagle, mayflies the size of pigeons, centipedes the size of cars, scorpions the size of dogs. And all these amazing creatures really once inhabited our planet. In fact, they were flying, running and crawling across all kinds of prehistoric landscapes. Top 10 Giant Prehistoric Bugs. Enjoy the video and don't forget to like and subscribe. This will show YouTube your content preferences so it can suggest more educational videos like this. This first insect on our list doesn't instill horror in modern people like many spiders do. We're talking about dragonflies. After all, they're not scary at all. On the contrary, many consider them beautiful and even cute, almost butterfly-ish. We love butterflies, don't we? But in prehistoric times, the earth was filled with dragonflies who looked more than just off-putting. Some of them would send you running away without a second thought. Introducing the Mayflies, a whole suborder of ancient winged flying insects. The wingspan of some species could reach 1 meter, 3 feet. This is what a Mayflies permiana dragonfly looks like next to an average person. Of course, it's unlikely that this monster would cause you any real harm. But it's still a monster. Many would get goosebumps just thinking that something like this could suddenly land on their head or arm. This creature was very adapted to the Paleozoic tropical forests. Unlike modern dragonflies, Mayflies spent their larval stage on land rather than in water. What did these terrible creatures eat to grow so big? They weren't sipping flower nectar as some people might think. After all, even modern dragonflies are predators, not to mention such monsters as Mayflies, who actually ate their kin, other insects. Moreover, Mayflies' menu predominantly consisted of the Dictyonoridae family. Modern dragonfly species are so tough that their larvae are predators too, consuming larvae of aquatic insects. So it is safe to assume that Mayflies larvae also weren't vegans. Presumably, they even ate tadpoles of Stegosaphalians, which was an ancient ancestor of modern amphibians. In general, the vital functions of Mayflies were quite impressive. The easiest way to understand their scale is by comparing ancient dragonflies with their modern peers and other insects. Here you need to understand that insects possess incredibly powerful and efficient muscles relative to their size compared to other types of animals. If humans had the same muscle capacity as ants, for instance, we could run at speeds of 60 kilometers an hour, 37 miles an hour, and lift loaded pickup trucks weighing 2 metric tons with our bare hands. Equipped with dragonfly-like wings and muscles, a person would also have the ability to fly and maneuver. But everything in this world has its costs. In particular, such powerful muscles require a huge amount of biological fuel or food. In a day, the herbivorous locust eats as much vegetation as it weighs. Predatory dragonflies eat much more energy-rich food, but they still consume about 30% of their own weight per day. Just imagine a 5th grader eating 35 kilograms, 77 pounds of cabbage or 10 kilograms, 22 pounds of meat per day. What a voracious appetite, right? To put this into perspective, an adult lion can eat about 7 kilos, 15 pounds of meat per day. And that's not how much it eats every day, but still, that is something. Let us consider a large modern dragonfly with a wingspan of about 10 centimeters, 4 inches, and a weight of, say, 1.5 grams, 0.035 ounces. If we scaled it up by 10 times to match a Mayflies, this colossal creature would weigh approximately 1.5 kilograms. That's about 3 pounds. Assuming the Mayflies was as gluttonous as today's dragonflies, and there's no reason to think otherwise, it would need about 0.5 kilograms, about a pound of meat per day. While not all Mayflies reached this size, with the average weight likely around 0.5 kilograms, 1 pound, their voracious appetite was undeniable. Now imagine such a dragonfly laying 250 to 300 eggs. These would be huge swarms of larvae eating everything in their path. What's remarkable is that Mayflies didn't seem to have any natural enemies. This means that there was no one to keep their population in check. Of course, not all of them survived from a clutch of eggs and grew into adults, but still, it seems that their population was growing at a very high rate. These larvae needed something to eat, and they clearly weren't starving to death. The abundant wildlife and rich natural environments of the Carboniferous period were nothing short of astonishing. After all, nature could sustain even such voracious and numerous creatures. But the Mayflies wasn't the only giant insect that would amaze a time traveler with its size. All kinds of monstrosities were flying in the air at that time. For example, Paleodictyoptera. By modern standards, these flying insects were also unbelievable giants. This wasn't just a single species, but a whole order of insects. And they are related to today's mayflies, which typically don't exceed 5 centimeters, 2 inches. Paleodictyoptera, and especially the Dictyonaridia, reached their biggest size at the end of the Carboniferous period, reaching 55 centimeters, 22 inches in wingspan. And there were about 200 species themselves. Unlike meganeurids, dictynarids were complete vegetarians, feeding mainly on the pollen of the first gymnosperms. They survived until the Permian period, 299 million years ago, though by then they'd significantly reduced their size. One plausible theory suggests that Paleodictyoptera were a primary food source for Meganeurus. One can only imagine these air fights when predatory giant dragonflies hunted their herbivorous relatives. Yep, imagining something like that flying in the air is pretty creepy. So let's go down to the ground. Maybe it won't be as scary there. Or so you might think. Would you like to meet someone like this in the ancient jungle, only 10 times larger? In fact, centipedes were also thriving in those days. A whole family of giant centipedes emerged called Euphoberidae. There were plenty of them in what is now modern Europe and North America. These creatures commonly reached lengths of 30 centimeters, 12 inches, dominating the ancient forest floors. At this point, some of our viewers might say, well, there are still huge centipedes today. Indeed, some species of modern centipedes may be up to 26 centimeters, 10 inches long. But in those days, euphorbiids literally dominated their habitats. For a time traveler wandering into such a forest would be, to put it mildly, quite an interesting experience. Fortunately, these creatures wouldn't attack or bite the poor fellow, unlike the next species from our list. You've all heard about scorpions and have probably seen them. Many people believe that scorpions are poisonous and very dangerous. However, out of the 1,750 known scorpion species, only about 50 pose at least some danger to humans. Still, it won't be the best idea to test whether a scorpion that has crawled into your shoe is venomous. But if you were to visit Scotland in the early Carboniferous period, you would come face to face with a scorpion so large it would be the one wearing the shoes rather than hiding in them. Meet Pulmonoscorpius, one of the largest genera of scorpions to ever roam our planet. Fossils of the largest known specimen have left scientists in awe, revealing that these monsters were over 70 centimeters, that's 28 inches, long. The largest belonged to a species known as Pulmonoscorpius kirktonesis. Its body structure was very similar to that of modern scorpions, only much larger. These creatures had rather big eyes, leading scientists to speculate that they might have relied heavily on their vision for hunting, much like most predators. While there is no absolute certainty, Pulmonoscorpius kirkitanesis were probably carnivorous hunters similar to modern-day scorpions. It's impossible to say how toxic their venom was, but the rule of thumb suggests that the smaller the scorpion's claw compared to the tail's thickness, the more powerful its venom is. Thicker tails can store more venom. This rule holds for modern scorpions as well. They may have hunted other large arthropods or even small amphibians and early reptiles. The relatively small size of the claws may indicate they either targeted smaller creatures or depended on their venom's toxicity to kill large prey and dismember it with their claws once it was dead. Here, take a look at the sheer size of the creatures that would cross your path if you found yourself in the early Carboniferous period. You can't help but think that traveling into the past may not be the best idea after all. Here are 3 extinct scorpion species. The first one is Styloneurus pariensis, the second is Brontoscorpo anglicus, and the third one, our most handsome boy, is known as Pulmonoscorpius crichtonensis. And since we've already mentioned arachnids, it's time to consider animals that terrify most people on the planet. Spiders. Were they also huge in the distant past? Well, why don't we just find out? Mongoloarachne jurassica is an extinct spider species and the sole member of the Mongoloarachnia family. Its fossil remains were found in the Inner Mongolia Autonomous Region in China. The genus Mongoloarachne was originally described quite recently, in 2011, as Nephila jurassica. Discovering this new prehistoric species was quite an event for the scientific community. Indeed, the term Jurassica isn't used lightly here. We're about to leap from the Carboniferous period straight into the Jurassic era. Nephila jurassica immediately gained widespread fame as the largest known fossilized spider. It's scary to imagine what kind of monster it was, even though some modern spiders can also be quite large. However, it's important to temper our expectations because ancient spiders had a similar size to their modern relatives. But before you get disappointed, remember that we can see how these ancient spiders behaved in the wild by observing some modern species that are closely related to them, especially given that they're almost the same size. The largest individuals of the species are, of course, females. Size-wise, the most impressive specimen was a female of Nephila clathopes found in Australia. Her body was almost 6 centimeters long, 2.3 inches. A leg span of 20 centimeters, 7.8 inches, is generally common for such spiders. The webs they spin can be over 1.5 meters, 5 feet in diameter, so it's not surprising that such spiders can occasionally hunt birds and bats. Most likely, the spiders of the Jurassic period weren't smaller than their modern relatives, and paleontologists have simply not yet uncovered the largest specimens. As with the most spider species, the males of the Mongoloarachne jurassica were significantly smaller than the females. This might suggest they had the same grim fate as their modern relatives, who are eaten in cold blood by females during mating. Their hunting techniques probably mirrored the complex and creative methods observed in some of today's spiders. For instance, some modern spiders domesticate real feats of intelligence and dexterity. They literally unwind the trapping net and throw it over their prey. The silk produced by the spiders is very stretchable and allows them to trap almost any insect. Some species drop their web over the prey from above, while others stretch it between their legs and wait for the prey to fall into it. Take a look how this happens. Amazing, isn't it? This really shows how intelligent those creatures are. In turn, the ancient Mongoloarachne were morphologically very similar to these super dexterous modern spiders. So there is a good chance that spider ancestors hunted almost the same way millions of years ago. Alright, we've covered ancient spiders too. What else is missing from our list of the top 10 gigantic prehistoric bugs? Ants, of course. Believe us, they won't fail to astonish you. You've probably long noticed grandiose prefixes in the names of giant extinct animals: Megalodon, Meganabvelia, Titanoboa, and so on. Ancient extinct insects have their own record holder with such prefix, Titanomyrma. This is not a distinct species, but rather an entire genus currently comprising 3 species known to science. Their fossils have been discovered in Europe and North America dating back to a relatively recent 49.5 million years ago. Titanomyrma lubae is one of the largest ant species ever found, whether extinct or extant. Their queen is comparable in size to a hummingbird. Like most modern ants, Titanomyrma was carnivorous. These ants were likely the predecessor of species that managed to kill even considerably large animals. They did this through a massive attack by surrounding the victim and stuffing it with venom. This kind of zerg rush is also commonly observed in modern ants, although their size is totally different. The largest living ant, Dinopanera gigantica, reaches a maximum of 3 centimeters, just over an inch, and is quite rare. In contrast, Titanomyrma dominated its habitat and was very populous. It's scary to imagine the size of the prey they were able to take down during their massive attacks. What you're seeing here, for example, is a dramatic footage of some ants overpowering a beetle, which is considerably larger than any of them. One might wonder, was there anything in the ancient forests that would interest Titanomyrma as a large prey? After all, it might be intriguing to imagine a fight between a crowd of Titanomyrmas and the largest terrestrial prehistoric bug. The only problem is that this creature and the Titanomyrma lived in different eras. Nonetheless, this monster deserves special attention even if considered out of context. Let's go back in our minds to 300 million years ago and to the very end of the Carboniferous period. Imagine yourself in the equatorial region of the supercontinent Pangaea, in what is now modern Europe or North America. Everywhere you look, there are vast swampy forests bordered to the north and the south by huge deserts. Here, in these impenetrable thickets, roamed this. We're getting back to where we started: centipedes. This is what Arthropleura looked like in real life. As researchers jokingly say about this creature, it's a centipede that can look you in the eye. This monster could easily grow to 1.5 meters, that's 5 feet long. It is only distantly related to modern millipedes, such as the 26 centimeter, 10-inch Julida. Arthropleura lived between 314 and 290 million years ago. They had a powerful shell and had the most terrifying look. Despite all of this, most likely they were completely herbivorous, which is evidenced by traces of fern spores found in the intestines of the fossils. It sounds like such a relief, but the creature still makes you feel icky. However, scientists have yet to determine Arthropleura's exact diet. The thing is that none of their fossils retained a part where their mouth was supposed to be. Arthropleura lived on grassy forest floor. It moved just like modern centipedes, dodging obstacles and curling into a ball when rolling down hillsides. But there's another interesting point. Arthropleura may have served the same purpose as modern butterflies. Of course, they didn't know how to fly. We're talking about the role they played in plant reproduction by dispersing fern spores when moving through the undergrowth. The largest specimens of this species exceeded 2.5 meters, 8 feet in length, and had 30 pairs of legs. They were protected by a powerful segmented chitinous shell covered with small spikes, increasing the protection of this fearsome creature. Scientists believe that the largest individuals weighed up to 50 kilograms, 110 pounds. Numerous Arthropleura fossils have been unearthed, but an equally fascinating find is the fossilized tracks of this giant millipede. Arthropleura's fossil tracks have been discovered in many places on our planet. They're basically 2 parallel lines of small imprints left by 30 pairs of legs. Most likely, Arthropleura left these tracks when swiftly moving through the forest floor, escaping predators by maneuvering around trees and rocks. The largest tracks, measuring 50 centimeters, 20 inches wide, were found in Nova Scotia, Canada, within 30-meter tall, 100 feet tall rock formations, now recognized as a UNESCO World Heritage Site. However, it's hard to come by a complete fossilized Arthropleura. The largest centipede specimen to date, comparable in size to a car, was found in 2021. It was discovered on a beach in northern England. According to the press service of the University of Cambridge, the find is about 326 million years old. It was described in detail in the Journal of the Geological Society. The specimen consisted of several joined exoskeleton segments resembling modern millipedes. It was about 75 centimeters, 30 inches long. Scientists estimate that the creature measured about 2.7 meters, nearly 9 feet in length, and weighed approximately 50 kilograms, 110 pounds. Scientists believe its substantial size was due to a nutrient-rich diet. The specimen also suggested that Arthropleura preferred to live in forest habitats near coastlines. Up until now, only 2 Arthropleura fossils were known, both much smaller than the new specimen and both from Germany. Well, we've covered the prehistoric giants that lived in the air and on the land, but we still have one more element left: water. Indeed, the ancient ocean was also filled with huge creatures resembling insects and arachnids. Now, let's head to the ancient ocean that existed between 360 and 290 million years ago. There, we'll soon meet a creature known as Megarachn. Science has identified only one fossil species of this genus so far, Megarachn cervini, and it's quite impressive. The fossil imprint found in sedimentary rock was 34 centimeters, 13.4 inches long. It is estimated that the creature's actual body length averaged 40 centimeters, 15.7 inches, and the limb span of the Megarachn cervini reached over 50 or even 70 centimeters, 20 to 27.5 inches. It's difficult to say exactly what this animal ate, but one thing remains clear: Megarachn was not wondering what to eat, but rather who. It was definitely a predator. By the way, the name Megarachn itself is translated from Greek as huge spider, though this creature was anything but a spider. Research conducted in 2005 showed that Megarachn was not a spider but a sea scorpion, and not even the largest of its kind. As for the largest one, please bear in mind for us just for a minute, our record holder is already on its way. Now, we can't overlook another striking member of the marine arthropods. The name Anomalocaris hints at the extraordinary nature of this creature. The term anomaly here doesn't suggest unusual dimensions. The name roughly translates from Greek as not like a shrimp. The fact is that when animal prints were first discovered on the rock, scientists spent a long time wondering how to classify them. It seemed like a peculiar type of shrimp or something entirely different. But whatever this arthropod was, it was gigantic for its time. Estimates suggest some species could grow up to 37.8 centimeters, about 1¼ feet in length, not including their frontal appendages and tail fans. Earlier estimates proposed lengths up to 1 meter, approximately 3.3 feet, but those were later deemed exaggerated. And even if this size doesn't impress you, wait until we discuss the true record holder of the sea. Pterygotus. Size-wise, among the huge number of sea scorpions, this particular genus deserved the title of a champion. It lived at the end of the Silurian and the beginning of the Devonian period, about 428 to 412 million years ago. Its first fossilized remains were found in 1844. The largest known species, Pterygotus grandidentatus, could grow up to 1.75 meters, 5.7 feet long, and it was not the only one. There were at least several species of similar size. Even more impressive were species like Acutimaris, which could reach 2 meters, about 6.6 feet, and Echolopterus stretching up to 2.6 meters, approximately 8.5 feet. In general, sea scorpions were amazing creatures and one of the largest predators of their time. A recent discovery in Scotland unveiled a track left by a large sea scorpion 330 million years ago, measuring 6 meters, around 20 feet in length, and nearly 1 meter, about 3 feet in width. It's believed that the creature that made these tracks was about 1.6 meters, roughly 5 feet long, moving in a slow, jerking manner that dragged its hind body across the ground, leaving a furrow behind. The sea scorpion's morphological structure suggests it struggled to drag its body on land. Who knows what put the animal into such a pickle? Did it end up on the shore by chance? Was it looking for food in such a strange place? Or was it a simple act of curiosity that drew it ashore? Despite the remarkable diversity of insect and bug-like creatures from our list, none of them have survived to this day. They all went extinct for various reasons. Some didn't have enough oxygen, others fell to interspecific competition, and some didn't survive the glaciation. Was there any chance for these giant animals to survive to this day as a species? For the most part, no, unless evolution had given them lungs by some kind of miracle. Under current environmental conditions, do modern insects have a chance to eventually become as large as their distant ancestors? Absolutely not, for the same reasons. And it's up to you to decide whether this is fortunate or not.